Hello everyone, we will solve this today's LeetCode problem. This is palindrome partitioning. It's a medium one. Let's see what it is. So we have given a string s, partition s such that every substring of the partition is a palindrome. Return all possible palindrome partitioning of s. Okay. So we have a given string and we need to partition this string such that every substring of that partition is a palindrome. So what is the palindrome means? Okay. The palindrome is a string that reads the same forward and the backward, right? So it means this AA, B, AA, this B, AA is it a palindrome? Yes, it is a palindrome because if you see from from left to right and right to left, this is both same, right? So is a single element a palindrome? Yes, it's also a palindrome, right? So we need to find a substring. We need to partition this string into a substring such that every substring of this partition is a palindrome. So if you see A, B example, so we can partition it like that: A, then B. Single elements are always a palindrome, right? Now, can we split into like this A or AB? No. Why? Because this AB is not a palindrome. So we can't split in like this. So we can split it AA and then B, right? This both are palindrome. So we need to return all possible partitions such that every partition has the substring which we form is a palindrome, right? So this is how we will form. Okay. So one thing you see here that the length of the string is very small. Length of the string is very small. The constants are very low. So if you see in this AAB, what we got, we need to partition each for partition. What we do, we just split this in two parts. Right? We just split into this part. The first partition we can do this like this. This A, this AB, right? The first partition is this is the first and this is the second substring. This partition is possible. Now this partition is also possible. This partition is also possible. Okay, this partition is also possible, right? Right. So if you see here, we need every substring of the partition is a palindrome in a palindrome, right? What does it mean? It means that if you see here, what we are doing, we are partitioning at each and every index, trying to partition each and every index and check that whether all the substring is a palindrome or not. So if you see here, this AAB, this A is a palindrome, but this AB is not a palindrome. So this will not be work, right? This will not be work. If you see here in this A and this B, this all are palindrome. So This will this will work. Uh, how to do that? Okay, this will work. This is okay, right? If you see here, this is AA and this is B. So this is also palindrome and this is also palindrome. So this partition will also work. So what we are doing here, what we are doing, we are go- we are we are partitioning. Try to partition. We are trying to partition partition at every each and every index and checking that the substring which is formed after partition is a substring or not, is a palindrome or not, is a palindrome or not. This is what we are doing. If you see here, we were partitioning at each index, at his zeroth index, then one index, right? So can we do like this, just like this, AAB? Yes, we can do that, right? This is also possible partition. Can we do like this AAB and this? Yes, we can also do that, but this and this is the same. If you see, this and this is the same. So this is not okay because this is not a palindrome in itself. This is also not okay. This is not okay, right? And this is also not okay. So we can we are doing each and every partition at every index, as 0th index, then 1th index, then 2th index, then last index, right? This is we are doing here. We are trying to do partition each and every step. So how we will do that, right? So let's see how we will form this, how we will partition this. So let's suppose here we have given B. So how we will can partition? Either I can put a partition here, right? Either I can put a partition here, and so let's make a recursion tree for that. That how we will partition and store in my answer, right? So the first option I have that either I partition at 0th position, right? Either I partition at 0th position. So for that, what I need to do, I will just partition it, right? And now I will only partition when we have palindrome possible, because here it is written that every substring of the partition should be a palindrome. So this is a substring which we got right till now. Is this a palindrome? Yes, it is a palindrome. So I can take this. So what I will do, I will initialize a vector also to store this substrings, because ultimately we need to return the substring now. So I will store this substring which is a palindrome, right? So I will just simply store this. I will just simply store this, right? Okay. Now this is a possible palindrome, right? Okay. Now what we can do is I have put a partition here also. So now again for this next option, what are the possible options we have? So for this option, either I can partition here, or I will say that let's try this. I have tried this part. Let's try this here. Let's try to partition here. So if I try to partition here, what it will be? It will give us, hmm, yeah, it will give us this A, and then B, right? This will give us, so this AA is a palindrome. So I can take this, right? I can take this. So we will, so how we will store? We will store this AA here. We will store this AA here, because I know na ki this is the palindrome, so it can be a possible answers for us. So we need to check each and every substring for a possible pair. So I have partition here, then I have partition here, and then I will have partition here. So there will be a separate, there will be a different, so there will be another case when, uh, let's try to include this here part, here. And so again I have option of a separate partition. There is a space constraints there, so I will write it here. It is just a part of this, right? It was just a part of this. So I have another options of what? I have another option of a partition here by partitioning at last position. So is this a valid palindrome? No, this is not a valid palindrome. So we will not include it. So this will be a no one can, this will not take, this is not okay, right? So we will not form this partition. So we will play for this only, for this two, right? So let us start. We have partition here. Now I have option of this AB. Either I put a partition here, or either I put a partition here, right? So if you see what two cases are we have, either I put a partition at A. So if I put a partition at this one part, so this A will become. So is this a valid palindrome? Yes, this is a valid palindrome. So we will include in my answer, right? We will include in my answer. So if this is a valid palindrome, I will include this answer. Okay. Either I can put a partition here, or either at last, because I need to check whole partition. Na? So if I put a partition at last, so is this a valid palindrome? AB. No, this is not a valid palindrome. So this is not okay. So I will neglect it. I will simply neglect that. This is not a valid palindrome. I will neglect that. So X means we will don't take this, right? So this is not an axis. This is X, right? So X means here, n- uh, not okay, right? Not okay. So we will simply not take this part. Now after this is the partition. Now after this is the end point. Now this is the end point. After this part, if you partition here, we will get return at, if you partition here after this, we will get empty substring. So is in this part, this is empty substring, there is no need to partition here. It means this, we have got our limit of the strings, we have got the limit of the string. It means I cannot partition, but I am confirmed that at this position, this substring which we have get with the partition which I have got at last position is a valid palindrome partitioning, because we are checking at each and every position that whether after partitioning the previous substring which we form is a partition is a valid palindrome or not, right? So I am confirmed at last position. I am confirmed at lastly that the partition which I got, the partition which I got as all the substrings palindrome, which I got as all a valid palindrome substrings, valid palindrome substrings, right? I'm confirmed about this. About this that I'm at last leave the partition which I got as the valid palindrome. Now, if you see here, I have included this AAB at here position. It means this B is also valid palindrome. So I will just include this in my answer. AB, right? I will just include in my answer, right? So now this is included. Now I need to if I have included in my vector in an array this B partition. So when I return back, I need to backtrack this. Backtrack means I need to delete this last insert value, so that if I move to any other its siblings for checking its valid palindrome partitioning, so that's need to be checked now. So that's why if I go to move to its previous value, uh, how will I show you? So if you see, after this returning, after from this we return, from here we return, right? So if we return here from here to its parent value, from here to here, right? Its parent value. So I need to backtrack this. If we return from last to its parent, so we need to backtrack this. Backtrack, what does it mean? We need to remove the last substring which we have added. Why we are doing this? Because it can be possible that we need to check for another siblings, right? So if we backtrack this, it means this AAB is a this AAB is a can be possible, right? This AB is possible. So after this part, this whole B is taken, and this after this part, this there is no any possible, because if we have already taken this B part, right? And after this is no partition will be possible. So this AAB can be my answer, right? It can be one of my answer, right? Okay. So this this is the partition which we got from here, which we have got. Now when we when we again return from this here to here, from this to here, this A will also remove to make this, right? Yeah, we will again backtrack this, right? And we have checked that this AAB is not possible, because we have already seen now that this A and this B AB, this AB, if I take this AB will not partition, so we will not take this. So this is to confirm that this will not happen. So but I need to backtrack to check this, that at this position, this 1th partition, this AB should not be included here. That's why I need to partition that for checking the next siblings, right? So after this A should be again backtrack to AAB. This need to be empty. This AAB should be empty. This AAB should be empty to put either A to A, right? So I need to partition at this. So this A should be backtracked. So I will remove this A to here, right? Now, now again I will check for this partition. So if I put at this AAB should include. Now for this AAB, what other options we have? Okay, let's shift this some left part, right. So just give me a second. Yeah, now it's good. Okay, so this AAB has a valid partition. Okay, right. Now for a party, for again partitioning, after this, either I can include this, right. I need to include this, so I will just include this here, AA B, right. So what will be the partition if I include this AA becomes B. So is this B a valid palindrome? Yes, it is a valid palindrome. It means we have got a valid partition, right. And after this, there is no any path occurs, because this is the last element which we have got after this partition. There are no elements which I can take. So this is a palindrome which I got. So after this backtrack, this B should be removed from here. So this will form A again, and this will, at this A, this will again need to backtrack, and this we I got an empty substring. Now I will check for the last, which is this part, this which is this part, which is this part. In this, what we have done, this part. So if I try to include this is not a palindrome, so I will not include in my answer. So this is not okay. So if you see at last value, if you see at last, this, this, and this at leaf nodes, this all are sorry, not this and this is a valid palindrome. So valid palindrome partitioning. So AAB and AAB, this both are we got. So what will I do when I get this partition at my last position, which when my current index is left, I will store this and this in my answer, in my in my answer. What I will do, I will just store this A, this A, and this B in my answer when I try to return, because after this there is no valid partition, and I am confirmed that at last I will got a valid palindrome partition, right. I will, so I will just store the that partition at last leaf which we got, which we get got in my answer, right. I will just store this. Okay, and here this is a valid palindrome partition, so this should not, this should be also inserted here, this should be also stored here, this way. So if you see, this is the our answer. So what we are doing, we are just iterating every time, we are just iterating every time, we are just iterating in a string and try all possible partition, and checking that after partition, after partition, the substring which has formed is a palindrome or not, palindrome or not. This is how we are seeing, right. This is how we are seeing. So what will the solve function here, so what will the approach here? So we will make a function which have index, a, simply a empty substring, empty string, empty string of vector, empty string of array, and what, and a answer which we included. Here is an answer, right. So this is we got here, and again this is an index, this is an index, and second is array of strings, array of strings, right. So we will try all the try all the possibilities from here to include it. Either I can partition at 0, right, either I can partition at 1, Either I can partition at 2. If so, this is how we will check for every partitions, right? And we will backtrack this when we try to return from here part. So how we will do that? So how we will do that? So let's see what we are trying to see. What we are trying to do is, uh, we are we have, suppose I have started, I have tried I tried I will partition at ith index. ith index I am trying to partition at ith index, right? So what will I check? Suppose this is a b, same example, right? Suppose I am try to partition at 0th position. So what will I do? I will check from this, that either if I include only one element, that is the a part, is this a palindrome? Yes, this is a palindrome. I will also try to this check this aa, this aa, is this a palindrome? Yes, this is a palindrome. I will try to include this aab, is this a palindrome? No, not palindrome, right? So we are just trying to, we are at ith index, and then we are moving to check that from this 0th to every part, this 0th to every part, this aa, this ab, after in this, right? From this current index to its all right values, I will check for all that at whether it is a palindrome. If it is, then I will include it, and I will then move it from there, right? Suppose I am at 1. Suppose I am at 1. I am at 1. So this AA is a palindrome, I am confirmed, right? From its left, I don't need to worry about, because I have already checked it. From this one, I will just check whether this A is a palindrome, right? For this one, I will check A is a palindrome. Yes, A is a palindrome. I will include it, right? Is AB is a palindrome? Yes, AB is also palindrome. Sorry, AB is not palindrome. So I will don't include this. It means I will just only see whether my current substring is a palindrome after partitioning. If it is, then I will just move in that direction only. So this one is palindrome after including this. So from the next part, what will I check? I will check for 2, right? And this ab is not a palindrome, so I will not check for the 3 value, right? I will not store this value and not check for 3. I will just check for 2, right? So this is how we will form this. Let's try to implement this, you will be better understand, right? So see, uh, let's try to implement this now. What we need a current array of string and a final array of strings to store all the partitions, right? So we need two things. What we need we need a string to store a partition, and we need a 2D array of strings which will store my all the partitions which we will get in this term, we will store in this answer, right? So first thing what we do, we need to call this solve function where we have passed the index and string, this string, where we pass this string, right? Now this should be a void function because we are not returning anything. This is the index and this is a string which we pass. Always try to pass by reference, not by pass by value, because it will create a copy. So always try to pass by value to save space, the complex space, right? Now the first thing what we need to do, we are seeing here that we are try to partition from the current index to the right of shift. So this current is at 0, this current is at 0. So I need to check from 0 to 1, 0 to 2, 0 to 3, 0 to 4, 0 to 5, till the length of the strings, that whether this part of substring is a palindrome or not. So for that, how will I check from 0 to 2, 0 to 1, 0 to 3? I will just start iterating from j is equals to I till j less than I. I will start iterating like this. from from that current index to the right of the string, I will check all the possible substrings now. So I will just iterating from ji to jn. Now I need to form a substring. I need to form a substring. What will be s dot sub str? This current index is I. Now this j I minus plus 1. So what this represent? This represent the length of a string. So suppose I am at 0 position a, and I want to include only a part. So that will be j minus I. 0 plus 1 is 1. So from 0 to I will take only one length. When j becomes I plus 1, it becomes 2. It means this a will include. When j again increment, it will becomes j minus I plus 1 plus 1, it becomes 3. So it will create a. So this is how we are forming every substring here. Now what we need to check that whether this substring is formed is a valid palindrome or not. So I will just check whether this substring is a valid palindrome. So just make a check function here. So I will just check whether this is a palindrome or not. So I'm just supposing here that check function will give me a palindrome. If this is a palindrome, I will include in my answer. Okay, so how will I include this? Okay, just thing here. I have also declared this temp here, and this temp here is same. So let's take it as ss substring, right? This is a substring. So what we are trying to see that this ss with the substring which we have formed is a palindrome. So I will include in my answer. So I will just push in my answer, right? And what I need to do, I need to move call this recursion function again for its for again for partitions. So what will I go this the greater than jth index, so j plus 1, right? J plus 1 and this s will be good. Now after this I need to backtrack also, because this will give me, this will generate again and again a valid partition. So after this partition, when I move to its parent, I need to backtrack also this. So for backtracking, it means I need to I need to remove the last element for that. So for that I need to remove the last element which we have inserted. I have inserted this after last position. I need to remove this also, right? Right, so that I can form another partition after this, because this will form another substrings, and we will check another substrings, and this will inserted another substring. So I need to backtrack this, right? So this is for backtracking. This is for backtracking, right? So and okay, so when will this recursion will stop? So if you see here, when we have stopped, when this string length is greater than equals to, and when its limit to is when it reached limit to its limit of size. So if I is less than equals to n, and what is n is a size of string. So when it's I is greater than equals to n, it means I got a valid partition, which at last position, because at leaf node I'm only getting the valid partition. It means I need to include this. So I will just include my partition, which is temp. So I will include in my answer this temp and return it from here simply, right? I will just return it from here. So this answer will create and store all the temp values. So this is how we will form, and at last I will just return my answer here. So why I'm making this globally? Because I need to, if I don't make it global, I need to pass this answer and temp. That will, you can also pass it like this from here, that this and temp and answer, but we can declare this here, right? So let's try to run this, whether we are implemented this correctly or not. So okay, we have not make a check function. So this is for checking. So this will be a bool value for checking palindrome. Okay, this will be so pass it by reference. Why? You already know that it will, if we don't by reference, it will create another copy of string that will take extra spaces, right? Extra time complexity also, right? So let's make a check function. So this is So let's make a check function here, L0 and R is equals to SS dot size minus 1. I think you already know how to check palindrome, right? So we will just check for last position and f last position and last position the first position, that whether it is equal or not. If it is not, I will return 0. If all are equal, if all are equal, I will increment the first position and the last, decrement the last position and return 1 at last. So what is it is doing? It is checking the first and the last element whether this is equal or not. If it is not equal, it will return 0 because it will not a palindrome. Otherwise, I will just increment to check further. Right? At last, I got it means if I don't return 0 from here, it means I have a valid palindrome, so I will return 1. Right? This is the check function which we have got. Right? So this is how we form this substring. So let's run this again. We have passed the sample case. Let's submit it. Yeah, we have successfully passed the all the cases. So now, what will the time and the space complexity? This seems to be interesting, right? So if you see here, what we are doing, we are partitioning at each and every position. I can partition here, I can partition here, I can partition here, I can partition here, every position. So it means I have option of partitioning at each and every position. So I have got a two option, so that will be O2 to the power n, right? Also, I have two options, and now also I'm checking for each and every substring which we have formed that whether it is a valid palindrome or not. So that will be we that need to iterate, that we need to iterating each and every substring O of n times. So that will be O of n, that will be again O of n into n. So for checking substrings, this to needs to be n, and for we have all have we have options for partition or not. That will be 2 to the power n. So it is a 2 into 2 to the power n into n, and the space complexity will be. So if you see here, we are storing. Okay, we are storing in my answer. So if you include this answer as a uh, extra space, so that will be that can be 2 to the power n. But if you don't include, then this temp is already this temp has inserted and pop back. So that will don't that will be O of n, because this because we don't store all the elements here, because we are at last emptying it when we backtrack this, right? So we don't take this. Otherwise, there will be a recursion stack space O of n. If you take that recursion stack space, so that will be O of n, and the auxiliary stack space will be auxiliary space will be O of 1 if you don't include the answer as a extra space, because that answer need to be ultimately written as my answer, right? So I will not include. This is for only recursion stack space, right? So this will be the time and the space complexity. So hope you liked it. Uh, so yeah, thank you. Bye bye.